Okay, so hi guys, today is day 12 of doing Leetcode daily until I get a job. So we are here with the two questions which are remaining for our tree series. That are two questions which are hard: binary tree, maximum path sum, and serialize and deserialize binary tree. Okay, so let's start with the first question now. So it's a pretty famous question: binary tree, maximum path sum. So we have to find a path through this tree, given tree, which has the maximum sum of its values. Okay, like in this tree, what can be the maximum path sum? We may think that let's start from 9, then minus 10, 20, 15. It could be maximum, but we can see that we have to find the maximum. So if we try this path, 7, 20, and 15, this will give us the maximum value, because here a negative is there, so it will decrease the value somehow. So it's just that we need to find the maximum sum of any path through this tree. Okay, and we cannot repeat any, let's say, what is this called? These are nodes and this is the path between them. We cannot repeat on any path. Okay, so that's the one thing about this question. And what we can do here is simple, that we can apply the recursion approach obviously here. And what we can do is that, let's say this is our node, this is one of its child, this is one of its child, and then one this, one this, this, and let's say this. Okay, let's just say this is the solution. Now we need to find basically all the possible cases, and on every step, whenever we have the answer, we will just compare to our current answer, and we will update it. If it is greater than the previous answer, we will update the answer and return the maximum answer then later. Okay, so how we will do it is that for any root, see, what is the principle of recursion is that we need to find it for small cases. For bigger cases, it will generalize itself. And for recursion, what we need is a stopping condition and a function which we want, and a functionality which we want to implement on the current question. Okay, so what we need to do for every root is that for every root we need to find the left path sum and the right path sum for any root. Okay, when we are at this node, what we will do is that we will try to find a maximum path sum for its left subtree, and a maximum path sum for its right subtree. Okay, including this root itself. Okay, so whenever, let's say, we get an answer of 7 from this side, and let's say we got an answer for 5 from this side. Okay, and then what will happen is that okay, now this could be any value x. Now the path could be what? 7. Let's say we will start from here, and this was the 7th path from here to here. Okay, and 5 was from here to here. So what could be our maximum path? If this x is greater than 0, let's just say, if this x is greater than 0, this 7 is already once saved in the answer. Okay, so maybe the maximum answer is already 7. If it is greater than 7, then only we will go with it. Okay, now this x is there, this 5 is there, this 7 is there. Now the maximum path could be this. In that case, the sum will be 7 plus 5 and plus x. Okay, this might be one of the cases. Okay, so but what could be the case is that only if this number is greater than 7, only then the answer will be that. Okay, otherwise the answer will be 7. Let's say x is minus 10, then the answer will be 2 only, right? This path will not give us the maximum path sum, so we'll return just 7. Let's just say that this is minus 5. Now if this is minus 5, why will we even try to include this in our answer? Because it will ultimately decrease the path sum. So we will just return 7 plus x. Similarly, if this is minus 7 and this is plus 5, then we will return just x plus 5. And let's just say if both are minus, then we will just return x if x is positive, right? So for every node we are searching for, we just have to find the left side answer. We have to find the answer for right subtree and left subtree. We have L plus R. Okay, L and R for left and for right. Now what we will check for that particular, see, we have we have to update this answer every time. This is our final answer which we are going to return. We have, after finding L and R, let's say at this, for this node we have found it, L and R. Okay, L and R is 7, L is 2. Okay, so what we need to do it at this point is L, let's say L is 5, R is L is 3, R is 5, and this was 2. Okay, so what we will do at this point is we will get a temporary sum, and that will be equal to what? That will be the max of what values? The max of 5 plus 2 plus 3. What will be it? 8. Maybe this is the maximum path sum, or it will be max of 5 plus 2. See, L plus R plus current root value. Maybe it's L plus root value, maybe it's R plus root value, or maybe it's root itself. So these are the 4 things. 8, 5 means L plus root value, R plus root value 7, and only root value 2. Whatever is maximum out of this, we will update the answer with this, which is 8. But we need to, this is also L of some node, right? This is left subtree for this root node, so we have to also return the final answer from this side, and final answer from this side is, it cannot include like this whole path and then this path also, because if we go this path we cannot go back here. So it can be either the right, either the left. Okay, so it will be just max of 3 or 5 plus the root value of it, which is 2, or the root value itself. Maybe they are both are negative. Okay, in that case this will be the maximum. So this is the thing we need to do, and in the code we will like understand how this thing is working. So we will just call the helper function for root, and we will just return our let's say answer. Let's declare this answer as a global variable, and we will write a function here which will take a tree node start root as the argument, and then if the root is null, then we will just return 0 because it has no value, so its sum is 0. Then we will find the L, means helper for roots left. It will automatically do all the things. We do not have to worry about this. Okay, recursion does the thing. We will find the answer for the right. Okay, now our int current sum for this node will be max of, it will be max of L plus R plus roots value. Maybe it's only L plus root value, maybe it's only R plus root value, or maybe it's just the root value. Okay, so these are the possible values of the current sum. Then what we have to return for this this particular path, this particular let's say this, let's just consider this as the root node, wherever we are. Let's say we are at 20, and let's just consider this as the root node. What will be returning for this root node? Will be returning what? Max of these two plus 20. Okay, but the current path sum for this is 7 plus 15 plus 20. That is in the current sum. Okay, and as I say, we will automatically obviously will do this. That let's consider this as int min, because they are negative values also. Okay, it will be max of answer and current sum, and the path will be what? Maximum of L or R plus roots value, otherwise just roots value, right? and we will return path here. I hope this is clear because this wasn't that much hard to understand, but that's fine. And if you don't understand this still, then maybe I need to improve my explaining skills. Okay, I put 0 here, put root. Okay. Yeah, it's working good. And fine. Okay, let's go to next question now. Serialize and deserialize a binary tree. So basically what's here is that serialization of a process is a process of converting a data structure into or object into a sequence of bits so that it can be stored in a memory or file or memory buffer or transmitted across a network connection link to be reconstructed later in the same or another computer environment. Design an algorithm to serialize and deserialize a binary tree. There is no restriction on how your serialization deserialization algorithm should work. You just need to ensure that a binary tree can be serialized to a string and this string can be later deserialized to the original tree structure. Okay. The same as so we need to follow this format, so please be creative and come up with a different approaches to yourself. Okay, so we need to serialize and deserialize this given tree. Okay, so okay, so for this question what we can do is we are given these two functions, we need to complete these. Well, okay, okay, so let's first try to deserialize the data. We are given with the root and we need to put it into a string. Okay, so we will what return, we'll return the, let's say, helper1 function. We will put root into it and answer into it. So we just need to make we need to follow a format which will be same in deserializing and serializing. So like a format, I meant to say, like, let's say in order traversal or pre-order, let's say pre-order. If we are serializing the given tree in pre-order format, then we will be deserializing in the pre-order format also. Okay, both will be the same. Then only we can see that in the pre-order after 1 it will come 2 and then will come 3, then will come null, then will come null, then will come 4, then will come 5. Okay, we will consider a complete binary tree in the string so that it won't be a problem to deserialize it, because serializing it easy, we can do it in any way, but while deserializing we have to keep track of the proper left and right childs. Okay, so let's make a helper function. It will return a string that is helper1 and let's just an answer. Okay, an answer will be obviously we will reference it because it needs to be seen, it needs to be updated in every recursive call. Okay, so if the root exists, then we will just do what is answer plus to string the root's value, and we will add a separator also, like we will add a comma also. We will handle this comma in deserializing, and if it is null then we will just, okay, we will, in that case we will do this. Let's decide a function which will be putting for a null. Okay, for null let's say we will use hashtag. If the element is null we will just use hashtag and obviously a comma after it, and we will return. Okay, this we have handled the root here. Okay, we have handled the root here. After the root, we will what handle what? We will uh, handle what? The roots left, because we are, let's say, following the pre-order, and here we will have the answer. And after, we will do this same for roots right and answer. It will serialize it. Okay, and we will just return the answer. We don't need to actually, if we are referencing this answer, we can just simply return answer here. We will call this function and we will return answer. Now we will deserialize it. Let's say, how will we do this is that we will keep track of the number of elements we have done. What are the number of elements in the tree? How will we know it? Is that let's say we have a variable and we will increment it every time whenever we encounter a comma, let's say, a hashtag, let's say, and a value, let's say. Okay, we will increment this counter every time whenever it's equal to string dot size, means data dot size -1. We have our complete tree ready, right? So we will just do this and we will return, let's say, helper2, and we will put root into it and I into it. Not actually root, it's data. Okay, now let's write the helper2 so if I is equal to s dot size, obviously we will do this also. Okay, if I dot size as let's take this as s dot size -1, we will just return null. Okay, there is no root, there is no tree. Okay, we'll do this, and let's say the current character, should we take character, because the node's value is 1000 to -1000, so we cannot take a character will take only one value. So let's say string current, that will be our current character. Okay, if and let's say we create a node also which is initially null, that's fine. And while we don't get a comma, okay, while si is not equal to a comma, means at comma it will break itself, we will get a value. Okay, while this is not equal to comma, we will do what? Current plus is equal to si, because the value of the node might be a multiple characters like 123 or any 2-digit number or 3-digit number, it can be there, right? And current plus si, and I will be plus plus. Okay, and when it's equal to this, we will break, and we have the character here, current. So now if current is equal to hashtag, means it's a null, then we will also return null, that it's nothing. Okay, else we will do what? Else we will do node is equal to new tree node. Okay, we will assign a value to it, that node's value, or we can do it right here, that as a string to integer, and what will be put into it is current. Okay, after that we will just do this for same, that nodes, as we said in the pre-order format, nodes left will be what? Helper2 and string and I, and nodes right will be what? Helper2 string and I, and we will return root. I guess that's fine, that we are getting to comma will store the current here, and we'll be getting the comma, will break from the loop. If the current is a hashtag, it's null, obviously we are storing it for null, and if it's not, we'll assign the node, this node we created here, a new tree node with the value of string to integer of current, and nodes left will be this, nodes right will be this is all the current value, this for the left and right, and similarly this is for the current value, this for left and right. So yeah, I guess it should work. Let's see. Okay, 23 and 3. 23. 23. Yes. Again, it's a 14th line. There are a lot of spelling mistakes I need to increase my accuracy in my typing. That's fine. What happened here is answer plus is equal to toString and that character. Okay, it's basically a string, so we must do this. I think this can be the problem. This can be a problem, and I think we should solve it also. Because there are multiple characters, so one single quote won't do the thing. If current is equal to current is a string, so we must like compare it with only strings. Okay. Yeah, here if current is a string, we must only compare it with the strings only. Fair enough. Return root. Oh no, it's not root, it's actually node. A lot of syntax mistakes. Okay. STOI does not have a valid argument. What does this mean? That in the terminate I have to call after throwing an instance of invalid argument. What in STOI? STOI have this, right? That's why I didn't do this. Let's do this. That nodes val is equal to STOI with current. Let's see if this works. Oh, again it's not working. What can be the STOI should work, man. I don't see any like okay. I don't see any reason why it's not working. Okay, that's fine. And we have this roots value, current is this, nodes value is string to integer, this is fine. Why is it not doing the thing? Let's say we just see out the current. What does it give us? थोड़ी देर बताऊँ, रुक जाओ, मैं मन्ना बेरो. So we have output as 1 here. Okay, so 1 is here, so it must be converted to like we are good with this. We just need to see why is it not working. STO is not working. String to integer in C++. How to do that? String to integer function STOI. It's fine, man. Let's say int value is equal to STOI current. Let's try to run this. Still not working. Okay, it's working now. So we will just put the value here. Why? Invalid argument. How is it invalid, man? It's a string, right? It's a string. String current. Nodes value. Value is fine. So why is it not doing this? I don't understand. I mean, it should be doing this. Why is STOI not working, man? How is it possible? How is it possible? STOI to current. What are the other ways? Is there any other way? String to integer using ATOI. Let's try the ATOI also, if that works. And let's see how the no matching function to ATOI is nothing, is it? Man, how is it this? STOI integer. Will it still not work? Type of. What do you mean with type of? Okay. How to print a type of variable in CPP? I remember it says something related to type of, but I don't exactly remember. Type ID dot name. Okay. Type ID a dot name. So it's basically type ID of value dot name. Anything after this? Yeah, it's a function. So let's try this. It's an integer. Fine. But I don't understand. Wait. Wait, what if it's saying that we are not getting a string inside it? What if it's saying this, that we are not getting a string inside it? And why it's not getting a string inside it is, it may be, we have handled the case for this, we have handled the case for a string. Okay, only case we haven't handled this when it can null or empty space. Or maybe a comma, right? Well, comma is I plus plus. Then we'll call this function, call this con left helper to si. Okay, yeah, got it. We didn't increment this I. So a comma is sent from here. When it follows the left function call, a comma will be coming in the strings that at ith position. So ith position will be a comma. It's comma, so loop will break and it will come here. So it STOI and comma is current. Okay, so that was why it was happening, I guess. Otherwise, it's fine. Yeah, we can just remove it, and it will just slow down our solution, obviously. So we'll try to submit again. 39 milliseconds. This time 31 milliseconds. Anyways, yeah, that was it. and we have done the trees questions also, so we will try to do. Next is graphs. So for the graphs we'll be doing tomorrow. I will try to cover as much as we can, but for today this is all. And we got a video of like 30 minutes. Fine. So that's it today. We'll meet again tomorrow. Bye guys.